Here we're going to look at some examples of how to solve a system using the substitution method. The substitution method is a method used where we take one equation from our system and you substitute it into the other in order to solve for a variable. Now this method is used most often when at least one or both of your variables in at least one of your equations has a coefficient of 1. So for example, take this bottom equation here. I can solve for the y value very easily by moving x to the other side. In doing so, I now have a y equals equation. So I can take my top equation, which is the 2x minus y equals 2, and I can substitute this y value into this equation here. So what's going to happen is we're going to end up with 2x minus, and then open a parentheses, and we have a negative 4x plus 3 equals 2. We need to take this negative and distribute it through our parentheses here. So we get that 2x plus a 4x minus 3 equals 2. So here combine your terms. 6x is equal to a 5, so x equals 5 over 6. This is the first solution to our problem. But now we need to solve for the second solution. So one of the things that I like to do is, since I used my top equation to find the first solution, I'm going to use the bottom equation, so the 4x plus y equals 3, to find the second. You're going to take your x and you're going to input it into the x value. So this is going to become 4 times 5/6 plus y is equal to 3. So in this case, we can reduce our 4 and 6. This becomes a 2 and this becomes a 3. So we are going to end up with 10 over 3 plus y equals 3. If we multiply everything here by that denominator, we can get rid of our fraction. So here we're going to end up with 10 plus a 3y is equal to 9. My 3y equals negative 1, so y equals negative 1/3. And this here ends up being my second solution. Now because we're solving for a system, your solutions will be written as a coordinate form. So 5/6, negative 1/3. Remember, we're always going to write things in terms of x comma y. Okay? Alright, let's look at another. So here we're going to do the same thing. You want to look at both of your equations and we want to see which of these equations here would be easily manipulated to solve for a variable. Well, in this case, notice in my first equation my y here has a coefficient of 1. So I'm going to go ahead and look at this first equation. So here I get that negative y is equal to a negative 3x minus 1. Make that y positive, so y is equal to 3x plus 1. Now I'm going to use my second equation, 7x minus 4y equals 0. I'm going to take this y that I just solved for and I'm going to input it into my equation. So here this is going to become 7x minus 4 times 3x plus 1 equals 0. Here I'm going to solve for my x. So in this case, 7x minus a 12x minus 4 equals 0. Negative 5x is equal to 4. so x equals -4/5. So there again is your first solution. Since we used the bottom or the second equation, we're going to go back to the original. So 3x minus y equals -1. I'm going to take this solution that I just found here, and I'm going to input it into my x. So here this is 3 times -4/5 minus y equals -1. This is -12 over 5 minus y equals -1. Multiply everything here by 5. So we're going to end up with -12 minus a 5y is equal to -5. My -5y equals 7. So y equals -7 over 5. Therefore, my solution is going to be -4/5, -7/5.
What's the blue one? See? That's what the blue one does.
Okay.
Red is for red meter, blue is for blue meter.
Let's try one more just to make sure that we have full understanding. So again, we are going to look for an equation that we can easily solve. Now, in both of these, if you notice, my x's and y's in both equations have coefficients. So in this case, you're just going to pick one. So let's go ahead and let's pick my top equation. So I'm going to solve for y. So I get that 2y is equal to -5x minus 10. I'm going to divide everything by 2, so y is equal to -5/2 x minus 5. I'm going to use my second equation, so 10x equals -3 minus 4y. And I'm going to go ahead and plug my y value in. So just like before, we're going to take what we found here and we're going to input it down in our equation. So we have my 10x is equal to -3 minus 4 times my -5/2 x minus 5. I need to distribute my 4 into my parentheses. So my 10x is -3 minus a 10x. So how did we get that? 4 times 5 is 20 over 2 reduces to 10. 4 and -5 is going to give me a positive 20. Now in this case, I want to take my 10x here and I want to move it across the equal sign. Well, because it's positive, I have to subtract. So in this case, I end up with 0 is equal to 17. Now what do we know about that? Well, that's a false statement. That is not true. So because we came up with a false statement here, this means that we have no solution. Since we got a false statement at this point, this is where you would go ahead and stop. We have no solution to this problem, therefore we would be done. So there you have it. You've got 3 very different examples of solving systems using the substitution method. If you have any questions, please feel free to let me know. If you have any solving system problems that you're not sure how to attack, you can go ahead and send those to me. I'd be more than happy to look at them and help give you some pointers to get you started. Otherwise, I do hope you enjoyed this video, and I'll see you next time.